Let's take a look at a problem with an image from a concave mirror. An object arrow is placed in front of a concave mirror having center of curvature C and focal point F. Which diagram best shows the location of point I, the image of the tip of the object arrow? And is the image real or virtual, upright or inverted? Now let's take a look here. In this first one, we have the ray parallel to the principal axis coming back through the focal point. We have the line from the center of curvature coming back that way. But I don't think that's going to work. Let's take a look. We've got a line from the center of curvature going through here in parallel. That's not how that works. Can't be one. Or number two, the line from the focal point through the object and then back off the mirror. That's not right. That can't work. Number three, we've got the line parallel to the principal axis from the image, goes through the focal point. That works. We also have the line through the center of curvature in the object going back through the center of curvature. That works. And then they're extended back on the opposite side of the mirror to give you an image. So our image would look like that. That's looking pretty promising. But notice in this case we're going to have a virtual image. It's upright. Yeah, that's got to be our answer. Because if I look over here at 4, well, that's just silly. The line from the center of curvature through the top of the object is going back at a goofy angle. That can't be right either. 3 must be our correct answer. The image is virtual and it's upright. Let's try one more. A candle is placed 0.24 meters in front of a converging mirror that has a focal length of 0.12 meters. How far from the mirror is the image of the candle located? Well, let's use our mirror equation. 1 over F equals 1 over DO plus 1 over DI, or if I do, I die. And we're looking for the image of the candle. So I'm going to rearrange this to say 1 over the image distance is equal to 1 over F minus 1 over the object distance. Then substitute in my values. 1 over DI is 1 over, our focal length is 0.12, and our object distance is 0.24. Therefore, 1 over DI must be equal to 1 over 0.12 minus 1 over 0.24. That's going to be 4.17 inverse meters, meters to the negative 1. Therefore, DI will be 1 over 4.17 inverse meters, which is going to be 0.24 meters. Hopefully that gets you started on mirrors, reflection, and ray tracing. Thanks so much for your time. We'll talk a little bit more about ray tracing as we explore lenses in our next lesson. Make it a great day, everyone.